dear children, so I am back with the third and the final video of the video series on lines and angles, and in this video we are specifically going to talk about parallel lines, intersecting lines. We will also talk about a very important concept which is transversal. So let us go ahead with the video and make our concepts crystal clear. I am Roshni from Learner Hub, the free learning platform that you get to study all about maths and science absolutely for free at learnerhub.com. And we also ensure that we upload a new video every day. So stay tuned and be with us and keep learning. So are you all ready to learn with me? Let's get started. So now that we have discussed about so many different types of angles, it is time to talk about types of lines. Now again, here also we will not talk about individual lines, rather we will talk about pair of lines. So the two common types of lines that we will talk about are the parallel lines and the intersecting lines. Now what do you see on the screen? You see the railway track. Now if you have ever traveled by a train, then you would have, and if you have observed the railway lines, you would have seen that normally the railway lines, they run together. I mean, two lines, they are always like running in such a way that the distance between the two lines remain the same throughout. So these type of lines would be called parallel lines. Whereas at certain places you will see that one line crosses over another line at a particular point. So these type of lines would be called the intersecting lines. So railway track is one such example where you get to see intersecting lines as well as parallel lines, I mean at the same place. So now we are going to talk about these two types of lines in more detail. So let's start with parallel lines. So these are lines which do not meet and maintain the same distance between them. So when you have two lines like this, such that the distance between them remain the same. So the distance at this place and the distance at this place, they will remain the same, and the lines will continue to extend infinitely, and still the distance between the two lines will remain the same. So that means these two lines will never meet, because there will always be this particular distance between them. So they will neither meet nor will they appear to meet. So these lines are called parallel lines. Whereas when we talk about intersecting lines, these lines, they have a common point because they cross over each other at a particular point. And this point where they cross over each other, this point is called the point of intersection, because this is the point where they meet. Now basically you might have examples like this where you do not see two lines actually meeting. For example, these two lines. What will you tell? Are they parallel lines or they are intersecting lines? Because in this case, these two lines do not really have a common point. Whatever is shown on the screen, that shows that they do not have a common point. But does that mean that they are parallel lines? No, because they do not satisfy the condition for parallel lines. In order to be parallel lines, the distance between the two lines need to be same throughout. But here on one side the distance is this much, and on the other side the distance is decreasing. So what is this picture showing? This is showing that the two lines have not met yet, but they will meet soon. So if you kind of extrapolate these lines, they are going to meet at a point. So basically these type of lines will also fall under the category of intersecting lines. Only those lines where the distance between the two lines remain constant throughout, they will fall under parallel lines. So let us look at this example. This is also an example of intersecting lines where the two lines have a common point. So this is the point of intersection and these two are the intersecting lines. Let us look at some interesting examples of parallel and intersecting lines. Let's think of this table. So where do you see parallel lines and where do you see intersecting lines? So in this case, when you look at these two sides of the table, what do you see? they represent parallel lines, because you see the distance between them is maintained the same, right? So had this table been tapered towards one end, in that case these two have not been parallel lines. But in this case, the distance between the two lines have been maintained the same. Therefore, we can say that these are parallel lines. Whereas when you look at this line and this line, they intersect at a point. They have a common point. So they represent intersecting lines. You look at any such example, whether you talk about an almirah where you can actually compare these shelves. So the shelves are arranged parallel to each other. You see there, the distance between them is maintained the same throughout. Whereas when you compare this side with this side, they are intersecting lines because they meet at a common point. You look at this stool. So when you look at the three legs of the stool, do you think that they are parallel? So now they are slightly slanted. So basically the distance between the two legs here and the distance between them here are different. So that is why these two lines do not represent parallel lines. They are also intersecting lines which are not intersecting right now, but they appear to meet. So they also fall under the category of intersecting lines. Similarly, you can look at a window pane, and there also you can see both parallel and intersecting lines. So now we talk about another interesting line, that is transversal. So what is transversal? So it is a line that intersects two or more lines at distinct points. That's interesting. So why do we call it a transversal? Okay, first let's see what is it like. It is like, let's say you have two different lines like this. Doesn't matter whether they are parallel or they are intersecting, doesn't matter. Let's say you have two lines, and if there is another line which intersects two lines at distinct points, at different points. So it is intersecting the first line at this point and it is intersecting the second line at this point. So this line is called a transversal. Now a transversal necessarily does not intersect two lines. It can intersect 2 lines, 3 lines, 5 lines, 10 lines, or even more than that. So basically a line that intersects multiple lines at distinct points is called a transversal. Now why is it called transversal? Now the word transverse, it literally means cutting lines or to lie across. Now when you look at this, you see this transversal lies across these two existing lines. So that is why the name has been given as transversal. So let's say that you have 3 lines which are again not parallel, they are all different directions. But if you could somehow draw a line which is intersecting all the 3 lines at 3 distinct points, then this line would be called a transversal again. Now, the transversal, whenever it intersects multiple lines, certain angles are made. So let us look at those angles made by transversal. So let us look at the various angles that are formed. So you see, when this line cuts these 2 lines, so many angles are formed, right? So these are all the angles that are formed. So let us name these angles. Interior angles. So what are the interior angles? Now, even before that, let us start naming the angles. Now the angles which are formed in the inside of the 2 lines. So here, inside would mean this region. Right? So this part would be inside and this part would be outside. So this would be inside and these would be outside. Similarly, these would be outside. So inside the lines means the area which is there, which is included within the lines, and anything outside that would be outside. So interior angles means the angles which are formed in the inside of the lines. And definitely these angles are made by transversal. So the transversal has to be one arm of the angle. So this angle, let's call this angle 1, this angle 2, this angle 3, and this angle 4. So these are all examples of interior angles. So angle 1, 2, 3 and 4 are the interior angles. Similarly, the exterior angles which are formed are those which lie on the outside. So basically these angles, let's call them 5, 6, 7 and 8. So these are exterior angles, angle 5, 6, 7 and 8. We also have a pair of corresponding angles. Now what are corresponding angles? Now these are those angles which are located at corresponding positions related to the two lines. Let's say if you compare angle 3. So angle 3 is located on the right hand side of the transversal. Now at a corresponding position for this line, do you have an angle? Of course, you have angle 5. So when you look at the position of angle 3 on this line and the position of angle 5 on this line, you see that they are located at similar positions. They are on the same side of the transversal. They are located above the line. So in this case also, this angle is located above the line. Here also the angle is located above the line. Correct? So we can say that angle 3 and angle 5 are a pair of corresponding angles. Similarly, can you tell me which would be the corresponding angle for angle 7? Yes, angle 1. So angle 7 and angle 1, they also form a pair of corresponding angles. Similarly, what would be the corresponding angle for angle 2? So for angle 2, it would be angle 8. So angle 2 and angle 8 also form a pair of corresponding angles, and finally angle 6 and angle 4 also form one set of corresponding angles. So these are called corresponding angles because they are located at corresponding positions relative to the two lines. Next we have alternate interior angles. So these are also interior angles, but they are alternate interior angles. For example, anyways we have 4 interior angles, right? 1, 2, 3 and 4. So alternate interior angles would be 2 interior angles which are located on alternate sides of the transversal. For example, angle 2 is located on the left hand side of transversal, angle 3 is located on the right hand side. So 2 and 3 are located on alternate sides. So you can say that angle 2 and angle 3 form a pair of alternate interior angles. Similarly, angle 1 and angle 4 form a pair of alternate interior angles because these are also located on the interior side and they are located on alternate sides to each other. Similarly, when you look at pair of alternate exterior angles, so definitely you will deal only with the exterior angles. For example, what would be the alternate angle for angle 5? So the exterior angle which is located on this side of the transversal. So angle 5 and angle 8 would form a pair of alternate exterior angles. Also angle 6 and angle 7 would form a pair of alternate exterior angles. Finally, you would also have pair of interior angles on same side of the transversal. So interior angles can be alternate, like 2 and 3 are alternate interior angles, but 1 and 3 are interior angles on the same side of transversal. So angle 1, angle 3, they are interior angles on same side of transversal. Similarly, angle 2 and angle 4 are also interior angles on same side of the transversal. So you see, these are all angles which are formed by the transversal and they have been given different name based on their positions. So now we talk about transversal of parallel lines, because when we draw a transversal on parallel lines, we see that a lot of relationships between these angles which we discussed just now establish. So whenever two parallel lines are intersected by a common line, so that common line is called the transversal. Now in case of parallel lines, these are the following relations that establish. That is, it is observed that the pairs of corresponding angles are equal. So you remember we spoke about the corresponding angle. So let's say if this is angle 1 and if this is angle 3. So these are corresponding angles. So as per this relation, angle 1 is equal to angle 3. Similarly, let's talk about this angle. Let's say that this is angle 2. And let's say this is angle 4. So angle 2 and angle 4 are also corresponding angle. So angle 2 is equal to angle 4. Similarly, if this is angle 5 and this is angle 6, so 5 and 6 being corresponding angle 5 is equal to angle 6. So a pair of corresponding angles are always equal. Second, pairs of alternate interior angles are also equal. Now which are alternate interior angles? In this case, angle 2 and angle 3 are alternate interior angles, right? So angle 2 is equal to angle 3. Similarly, which is the alternate interior angle for angle 5? This angle, let us call this 7. So angle 5 is equal to angle 7. Now these relationships hold true only in case of parallel lines, only when the transversal is intersecting parallel lines. Pairs of interior angles on the same side of transversal are supplementary. Now, which are the interior angles on same side of transversal? Maybe angle 5 and angle 3. So as per this, angle 5 plus angle 3 is equal to 180 degree. That is, these are supplementary. Similarly, angle 2 plus angle 7 is equal to 180 degrees. So these are certain relationships which hold true for transversal intersecting parallel lines. Now that's important. Now you might wonder that why is it that suddenly for parallel lines so many angles have become equal, like the corresponding angles became equal, alternate interior angles became equal. So in order to understand that, we will prove each of these facts one after another. So let us first try to understand why the alternate interior angles are equal in this case. Now, we basically want to prove that why, let's call this as angle maybe 1. Let us call this angle 2. So we basically want to prove here that why is it that angle 1 is equal to angle 2. So we want to understand why this is true, right? Now, there is definitely a mathematical proof to verify why angle 1 is equal to angle 2. However, that proof will involve congruence theorem, which you will learn in your higher classes. So that mathematical proof you will learn when you go to your class 9th. But for now, I want to explain you that why this relationship holds true for only parallel lines and not for non-parallel lines. So we will have a look at it. Now just looking at this diagram, let us mark these angles also. Let us mark this as angle 3 and let us mark this as angle 4. Now looking at this diagram, you can say that angle 1 and angle 3, they together form supplementary angles. They form a linear pair. So angle 1 plus angle 3 is equal to 180 degree. Similarly, you can say that angle 2 plus angle 4 is also equal to 180 degree. So from these two, you can say that angle 1 plus angle 3 is equal to angle 2 plus angle 4, right? Now we also know that angle 3 is not equal to angle 2, right? Because looking at this, you can very easily see that if this is an obtuse angle, then this is going to be an acute angle. Similarly, when this is an obtuse angle, this is going to be an acute angle. Looking at the diagram only, forget about the relationship. When you look at this diagram, let's say that these two lines are parallel. So if you draw a 90 degree like this, similarly if you draw a 90 degree like this, what do you see? You see that angle 2 is greater than 90 degree, and here you see that angle 3 is less than 90 degree. So that is how it is. So we know that angle 3 and angle 2 will never be equal. Similarly, angle 1 and angle 4 will never be equal, because in both of these cases, if one angle is acute, the other angle is obtuse. So they both can never be equal. So in this relationship, when you look at this relationship, this angle 3 and angle 2 will never be equal. Similarly, angle 1 and angle 4 will never be equal. So the other possibility that is left out is angle 1 can be equal to angle 2. Similarly, angle 3 can be equal to angle 4. Now, there is also a possibility where you might say that, okay, it is also possible that none of these are equal to each other, but still their sums are equal. Yes, that is also very much possible. But in this case, what I am trying to show you is, mathematically, we get certain hints that there is a possibility that angle 1 can be equal to angle 2. Similarly, angle 3 can be equal to angle 4. Now the question is, what goes wrong in case of non-parallel lines? Now in case of non-parallel lines, let me draw non-parallel lines. Let's say these are non-parallel lines. When we draw a transversal, what happens is, here let's say this is the angle and here this is the angle. So if this angle is obtuse, this angle becomes acute. Do you know why? Because this line itself is moving in the upward direction, right? Because the two lines are tending to meet each other. Therefore, what happens? The orientation changes, that is the angle changes. Therefore, here this angle is acute and this angle becomes obtuse. Similarly, if let's say that if two lines are moving away from each other, in that case, here the angle would be acute, but in this case, the angle would be obtuse. So, whenever you consider non-parallel lines, their alternate angles will change. In a similar way, their corresponding angles would also change, and the sum of the angles on the same side of transversal would also change. So, this entire relationships, they develop just because the two lines are parallel. When the two lines are parallel, this equality of the angles hold true. Now try to understand why the sum of the interior angles on same side of the transversal is 180 degree. So basically here what we want to prove is, if this is angle 1 and if this is angle 2, so we want to prove that angle 1 plus angle 2 is equal to 180 degree. So this is what we want to prove. So we will be able to prove this, but we will make use of the previous property, that is the alternate angles are equal. So let's try to prove this. Now let's call this angle as angle 3. Now we already know that angle 1 plus angle 3, that is angle 1 and angle 3, they form linear pair. So angle 1 plus angle 3 is equal to 180 degree. So this is something already known to us. We also know that angle 3 is equal to angle 2 because these are alternate interior angles, because we know that these two lines are parallel and they are alternate interior angles, and alternate interior angles are equal. Therefore, we can substitute the value of angle 3 in this equation. So what do we get? Instead of angle 3, we can write angle 2 because angle 3 is equal to angle 2. So what do we get? We get angle 1 plus angle 2 is equal to 180 degree. Hence proved. So this is how we can prove that sum of the interior angles on same side of the transversal is 180 degree. Let us also try to prove that why the pairs of corresponding angles are equal in case of parallel lines. So in this case, let us name this angle as 1 and this as 2. So we need to prove that angle 1 is equal to angle 2. So how do we prove this? So here, let's say this is angle 1 and let us call this angle as angle 3. So angle 1 plus angle 3 is equal to 180 degree because they form linear pair. They are supplementary angles and also adjacent, so they form linear pair. Similarly, we can say that angle 2 plus angle 3 is equal to 180 degree. Why is that? This is what we had proved just in the last slide. This is because sum of interior angles on same side of transversal is 180 degree. On same side of transversal is equal to 180 degrees. So that is why you can say angle 2 plus angle 3 is equal to 180 degrees. Now looking at these two equations, you can write angle 1 plus angle 3 is equal to angle 2 plus angle 3 because the values of both of these is 180 degrees. So angle 1 can be written as angle 2 plus angle 3 minus angle 3. So this would cancel out to keep 0. Therefore angle 1 is equal to angle 2. So hence proved that the pair of corresponding angles are always equal in case of parallel lines being cut by a transversal. So this is how we have proved that why the corresponding angles are equal, why the sum of the interior angles on same side of transversal is 180 degree. However, we did not prove why alternate angles are equal because it would be little difficult for you to understand the exact mathematical proof at this point in time because you are not aware of the congruence theorem. Okay, so Now let us look at these lines. Where do we see them in real life? So do we see the transversals in real life? Do we see these kind of lines? Yes, of course. The most common example would be the example of a ladder. I'm sure all of you would have seen and used ladder. So when you look at the ladder, you see that the steps of the ladders, they are just like parallel lines. They are all parallel to each other. And when you look at this rod of the ladder, it is like a transversal, which is intersecting these multiple parallel lines. So this one is like the transversal and these are like the parallel lines. So that's one transversal that you would have seen. The second transversal would be on the railway lines, the railway track. So here also you would see that these these metal rods which are laid on the railway track, they run parallel to each other, right? And there is this line which intersects these parallel lines or which cuts multiple parallel lines. So this basically acts as a transversal. You think of a balcony or maybe a staircase where you have this kind of fencing or this kind of boundary around it. So when you look at this boundary here also, you see that these are like parallel lines, and this line which intersects all of these parallel lines at the same time, this is like a transversal. When you look at a road, a highway or a street like this, and especially when you look at the junction from where you have multiple lanes going in. For example, here you have a lane going this side, you have a lane going this side, you also have a lane going this side. So like it's like there are 4 or 5 routes that is getting connected through this junction. So when you look at it, you see that these lines are parallel, right? And these lines which are drawn here, what are they doing? They are basically cutting these parallel lines, right? So this is acting as a transversal. So these are certain scenarios where you can actually visualize the existence of transversal. You can actually see lines intersecting multiple lines at distinct points. So based on whatever we have learned so far, we will quickly look at some of the questions based on intersecting lines, parallel lines and transversals. Question number 1. State the property that is used in each of the following statements. If A parallel to B, then angle 1 is equal to angle 5. So let us say that this is A, this line is A, this line is B, and these two lines are parallel to each other. So this is how we denote parallel lines, that is the two lines saying that A and B are parallel to each other. Then angle 1 is equal to angle 5. Why these two angles are equal? Because they are corresponding angles. So the first property would be pair of corresponding angles are equal. So pair of corresponding angles are equal. If angle 4 is equal to angle 6, so this is angle 4 and this is angle 6. So these are alternate interior angles. So since alternate interior angles are equal, therefore the lines are parallel, because alternate interior angles are equal only when the lines are parallel. Angle 4 plus angle 5 is equal to 180 degrees. So angle 4 plus angle 5, which is this property? This property is sum of interior angles on same side of transversal is equal to 180 degrees. On same side of transversal is equal to 180 degrees. So these are the 3 important properties with regards to transversal on parallel lines. Question number 2. In the adjoining figure, P is parallel to Q. Find the unknown angles. That means you will have to find the values of A, B, C, D, E and F. So let us start with the simplest one, which can be found most easily. Now as we know that these two lines are parallel, so this angle is known. So which would be the corresponding angle for this angle? So an angle which lies over this line on this side of the transversal above the line. So angle D is corresponding to angle 125 degree. Therefore the value of D would be 125 degrees. Because they form a pair of corresponding angles. So we found out one angle. Now when you look at angle D and angle B. These are vertically opposite angles because you see this line, and this line. They are intersecting lines, and B and D are opposite angles on the intersecting lines. Therefore, B will also be equal to D, that is equal to 125 degree, because these are vertically opposite angles. Now let us talk about A. Now when you look at A and B, they form linear pair, right? Because they are located adjacent to each other. They also give a sum of 180 degrees. Therefore, we can say angle A plus angle D is equal to 180 degrees. This is due to linear pair. Therefore, A would be equal to 180 degree minus B. That is 180 degree minus 125 degree, which is equal to 55 degree. So we found out A, we found out B, we found out D. So what would be C? Again, A and C are vertically opposite angles. Therefore, C will be equal to A will be equal to 55 degree. That is because they form vertically opposite angles. So we now know A, B, C, D. So now we are left with E and F. Now E and F will always also be equal to each other because these are also vertically opposite angles. So these are the two intersecting lines. One is this line and the other one is this line. So E and F will also be equal, but we'll have to find out at least one value. Now when you look at angle E and angle A, can you establish any relation? Of course, they are also corresponding angles. So angle E is equal to angle A is equal to 55 degrees because these are also corresponding angles. Now angle E is 55 degrees, so angle F will also be equal to angle E, that is 55 degree because they form vertically opposite angles. So you see, just with these concepts of vertically opposite angles, corresponding angles, we could actually find out so many unknown angles. So we found that angle E is 55 degree, angle F is also 55 degree, angle A is also 55 degree, B is 125 degree, C again is 55 degree, and D again is 125 degrees. So that's how we could find out all these values. Question number 3. In the given figure, the arms of two angles are parallel. So, which are the arms of two angles? That means AB, this actually means that AB is parallel to DE and BC is parallel to EF. If angle ABC is equal to 70 degree, then find angle DGC. So DGC would be this angle. Now when you want to find angle DGC, here you just focus on this part of the image which shows that AB is parallel to DE and BC acts as a transversal. So BC is a transversal on AB and DE. That is how it is. So therefore you can say that angle DGC is equal to angle ABC. Why? Because these are corresponding angles. Therefore, what is the value of angle ABC? It is 70 degree. Therefore, you can say that angle DGC is also equal to 70 degree. So the first part is done. So this angle is 70 degree. Now let us look at the second part where we have to find out angle DEF, that is this angle. Now here you focus on this part where BC is parallel to EF, that is given. So here DE acts as a transversal. So DE is acting as a transversal. Therefore, which are the corresponding angles here? This angle and this angle. Therefore, angle DGC is equal to angle DEF because these are a pair of corresponding angles. Now, DGC we have just now calculated as 70 degree. Therefore, angle DEF is also equal to 70 degrees. Question number 4. In the given figures below, decide whether L is parallel to M. So let us look at the first figure. So we have to find out if these two are parallel. Now these two would be parallel only when one of those conditions are true. Either the corresponding angles are equal, or the alternate angles are equal, or the sum of the angles on the same side of transversal is 180 degrees. So one of these has to be true. So here we are given 57 degree as this angle. Let us call this angle as angle 1. So let us try to find out angle 1, because if these two are parallel, then angle 1 should be equal to 123 degrees, because these are corresponding angles. So let us try to find angle 1. Now angle 1 plus 57 degree is equal to 180 degree. That's because they form linear pair. Therefore angle 1 is equal to 180 degree minus 57, which is equal to 123 degree. So this angle 1 is 123 degree. So this angle and this angle, these are corresponding angles. So we see that the corresponding angles are equal. So now you might ask that why is it that only if one of these property holds true, the lines are parallel? That's because when the corresponding angles are equal, the alternate angles will also be equal, and then the sum of the interior angles on same side of transversal would also be 180 degree. Because you would have seen, right, when we proved each of these properties, we made use of the other property. Right, when we wanted to prove that the corresponding angles are equal, we made use of the property that sum of the interior angles on same side of transversal is 180 degree. Similarly, when we wanted to prove that the sum of the interior angles is 180 degree, then we made use of the property that alternate angles are equal. So all these properties are kind of interlinked to each other. So even if we are able to prove one of these, we can say that the lines are parallel. Let us look at the next figure. So here we have to prove if L is parallel to M or not. By looking at the figure itself, we feel that they are not parallel, because you see the distance between them is changing with time. So they will not be parallel, but we have to prove that mathematically. So if these two are parallel, this would be the transversal. So for this 75 degree, this would be the corresponding angle. So let us call this angle 1. So angle 1 plus 75 degree, that is 1 plus 75 degree is 180 degree, because it forms linear pair. Therefore angle 1 will be equal to 180 degree minus 75 degree, which is 105 degree. So basically this angle is 105 degree. So this angle and this angle are not equal. So therefore angle 1 is not equal to 75 degree. Therefore L is not parallel to M. Now when the corresponding angles are not equal, the alternate angles will also not be equal, and therefore the lines would not be parallel. So with this, we have reached towards the end of this lesson on lines and angles, and I hope that this lesson would have helped you. So in geometry, it is all about a very good observation and more practice, obviously. So I would advise you to practice more and more questions, not only from NCERT textbooks. You can pick up other textbooks and start solving questions, and I am sure you will gain a lot of confidence. So with this, I would conclude this lesson. See you all on the next lesson.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.